Lesson 5, where we're talking about geometric series now and sequences a little bit more. So we're getting to the sequence part of geometrics, and it doesn't look like we're going to get too much into the series of geometrics today. So we'll be getting the series next class. So excuse me, this is geometric sequences. So as we talked about in Lesson 1, geometric sequences are multiplication patterns. Okay, so if we look here at this warm-up, let's consider the following two sequences, 2, 4, 6, 8. So it's going up by 2s. So this right here would be an arithmetic. It wants us to figure out T5 and T6. So T5 of I and T6 of I, and then double I, we want T5 and T6. So for T5, for first one would just be a 10, and then 12, it's going up by 2 every time. And then for the other one, it's doubling every time. It's going times by 2. So it's going to be 32 and then 64. Okay, and right there is a good example of the difference between the multiplication and addition. Okay, sound down a little bit here. Okay, all right, and then as we get in here to the actual definition of sequence, which we already know, okay, sequence where each term is obtained by multiplying the preceding term by a constant is called geometric sequence. For example, 3, 6, 12, 24 is a geometric sequence of multiplying by 2. The value of the constant can be found by dividing the second term by the first term, or by dividing any term by the previous term. So that means that as long as you take T2 divided by T1 or T4 divided by T3, it's going to kick out your constant of 2 in this case. Okay, if T2 over T1 is 6 over 3, T4 over T3 is 24 over 12, both of them equal 2. Okay, the constant in the geometric sequence is called the common ratio. Now this is a variable you're going to get familiar with. I haven't used this yet because common ratio is only for geometric. So common ratio is right here in this formula. So it's your term over the term minus 1, so the previous term. Its exact relationship is these right here. Okay, and it can only be when n is greater than or equal to 2, because if it's 1, you can't do T0. That's all that means. And n has to be all natural numbers, which means no negatives. Must be in the positives. Okay, let's go ahead and look at this here. Okay, so example 1. Explain why each of the following are geometric sequences. Okay, let's try and figure out they're all geometric sequences. Why? Well, let's go ahead and figure out what their common ratio is, and if it has a common ratio, then it's geometric series. So I'm going to go 12 over 6. That's T2 over T1. I also have 24 over 12. All I need to do 2. T3 over T2. I get 2. So R equals 2. So it's geometric because it's multiples of 2. Okay, the next one, we'll go 5 divided by negative 1. That equals negative 5. Negative 25 divided by 5. That equals negative 5. So their common ratio is negative 5 here. So then it also has geometric multiple of negative 5. Okay, and then this one here, we got negative 5 over negative 10. That's 1/2. We have negative 5 halves over negative 5. That's also 1/2. So this one has a common ratio, and this is just fraction work. Okay, if you're confused on it, remember the 1 goes to the top, the negative 5 goes to the bottom. If you simplified this, you would get negative 5 over negative 10, which negative 5 over negative 10 reduces to 1/2. Okay, so the ratio on this one is 1/2, and then it'd be it is geometric because of that by multiples of 1/2. Remember, I say multiples of 1/2 instead of divide by 1/2 because we want to keep all of our geometric series in terms of multiplication, all our arithmetic sequences and series in terms of addition, even if it's adding a negative. Okay, so example number 2. For the following sequences, identify the type of sequence, arithmetic or geometric. State the common difference or common ratio. So here's a good thing to underline here. We have two, remember, we have common difference. That's our D in arithmetic. Common ratio, that's our R for geometric. So make sure we understand the differences there. And state the fifth and sixth terms for each. So 8, 24, 72, that looks like it's multiplying by 3 to me, but let me double check. 24 over 8 and 72 over 24, both equal 3. So they have a common ratio of 3. So for part 1, it's a geometric. For part 2, it's a ratio, common ratio of 3. And for part 3, I need to do the fifth and sixth terms. So I have to multiply 216 by 3. That's going to be 648 is T4 or T5. And then T6 is 1944. Okay, so I answered all the questions there. Okay, part B, 108, 72, 36. Okay, 108, 72, 36. So this one looks like, let's see here, we can try it. 72 over 108, and we can do 36 over 72. 72 over 108 is, looks like 2/3. This is 1/2. So they don't have a common ratio, so it's not geometric. It's going to be arithmetic. And in this case it is. It's arithmetic. It's going down by 36. Okay, so the common difference is negative 36. My T5 is negative 36, and my T6 is negative 72. Okay, I'm going to clean my writing here a little bit. Okay, I'm going to go ahead and erase this so I can have a little more room for C. All right, for C, so let's go ahead and set this up here. So 2 over negative 3, that's the first one. And the second one is negative 4, 3 over 2, which bumps up to here to make it negative 4 over 6, which reduces to negative 2 over 3. So we have a common ratio of negative 2/3 from this one here and this one here. Okay, so my first answer, that means it's geometric. My second answer is common ratio of negative 2/3. And my third answer, I got to go T5, I have to do T6. Okay, my T5 is going to be a negative 16 over 27. Okay, and my T6 is going to be a positive 32 over 81. Okay. All right. Just going on the investigation here. All right. So investigating the formula for the general term of the geometric sequence. So remember, we have that general form from our arithmetic series. We're going to, or sequences, excuse me. We're going to try to find the general form for the geometric. So consider the following scenario: University of Marine Biology student studies the growth of a strand of moss by observing the change in weight every day. The table shows the mass of moss in grams at 12 noon on each of the first 4 days. So here's the mass, okay, and you can see it's growing by geometrically, okay. State the common ratio. So 12 over 8 is what I want to do here. Whoops. 12 over 8, I get 3 over 2. 18 over 12, I get 3 over 2. So the common ratio is 3/2. Okay, let A, the first term, R, the common ratio, complete the following table. So first term is 8, T1 equals A, okay? A times 1.5 is 12, T2 is AR, so we're just going to keep going here. So it's going to be 1.5 times 1.5. That's going to be AR cubed. Oh, and it equals 27. Now it's R cubed because think about it, every time it hits, you're multiplying by 1.5 again and again, so we need to use exponents for this. Okay, so T5 is going to be the same 8 times 1.5, 1.5, equals 40.5, or AR to the fourth. Okay, and then it's going to be AR to the n minus 1. As you see, the relationship is this is a 5, this is a 4. So the exponent is always 1 less than the n. Okay? And you don't have to put anything in here because it's pretty much right there. So this formula is actually a little bit easier than the previous one, not as much solving or simplifying. So right here is your important formulas. There's two ways of writing it. The only difference is the A or T1. Term 1 and A are the same thing to us, so it doesn't really matter. But it's first term times R, which is common ratio, to the n minus 1. So whatever term number to the minus 1. Again, this right here is a part I might highlight if I was you. Pretty much outlines the information in the formula. Okay. All right, let's go on to some examples using that here. Okay, determine the formula for a general term and hence calculate the indicated term for each of the following. So we want to calculate T9. Okay, so by calculating T9, I need to make sure I have my formula here. So I know I'm doing T sub n equals A to the R n minus 1. So the information I need is I need n, I need A, I need R. So I got to figure out the common ratio, got to figure out the first term, I got to figure out the term number they want. Well, the term number they want is 9. It's right in the problem. The first number they got is a 5. My common ratio, 15 divided by 5 is 3, 45 divided by 15 is 3. My common ratio is 3. Okay, so to figure out T9, all I have to do is T9 equals 5 times 3 to the n minus 1, 5 minus 1, or excuse me, 9 minus 1 is 8. 5 times 3 to the 8, which will then kick out for my term 9 is 32,805 by putting that into your calculator. Okay, let's try B. Okay, so with B, oops, I don't have to write B, do I? For B, I have A is 1/3. The n they want is 7. Okay, and then my R I need to figure out really quick. One thing you'll know is a geometric series, if your ratio is a negative, it's going to alternate negative, positive, because if you do that, remember a negative times a negative is a positive, and then a positive times a negative is a negative. It's going to keep flipping back and forth. So make sure when you understand, you see this one negative here, your common ratio is going to be negative for this. I know it's going to be because it has to be in order to alternate it. Okay, so 1/6 divided by 1/3, okay, that's going to be 1/2. So it's going to be negative 1/2. You can kind of see that just because if I multiply 1/3 by negative 1/2, it gives me 1/6. If I multiply negative 1/2 by negative 1/6, it gives me 1/12. Okay, so here's what we're going to do is, this one's getting smaller as you can see. So we're going to have term 7 is 1/3 times 1/2 negative for the R to the n minus 1, which is 6. This is going to give us a positive 1 over 192, and we put it into our calculator. Okay, just got a couple more. All right, Janice and Gary are trying to determine the number of terms in the sequence 32, 64, 128, and 16,384. Okay, use the general term formula, right, simplify the equation to be solved to figure out the number of terms. So just like we did the arithmetic, it gives me the end. I need to figure out what term number that is. So I'm going to work backwards. So we're going to go to our general, what they're talking about this, okay, and we're going to plug in everything we know. So we know what T sub n is. T sub n is this right here. We don't know what n is. So 16,384 equals A, 32, okay, and times the common ratio, it's doubling. So we do know A is 32, R is 2. Okay? But we don't know what N is. Okay? And so now what we're going to do is we're going to go ahead and solve as far as we can. So I'm going to divide the 32 over. And that gives me 512 equals 2 to the n minus 1. Okay? So she used guess and check to kind of figure out what this answer would be. So what she's going to want to do is you want to figure out 2 to what power equals 512. Okay? 2 to what power equals 512? And you're going to figure out that we want 2 to the 9th is 512. Well, if we want this to become a 9, what minus 1 is 9? 10. So we actually want our n to be 10 terms. So this up here is the 10th term in the sequence. Okay, there's another way you could use it. I'm going to kind of just briefly go over with your calculator here. In your calculator, you can put in y1 into your calculator for the graphing part, 2 to the x minus 1, and then y2 equals 512. And then do the intersect feature. Okay, and the window you can use, so for you guys follow along here, give you some time. The window, because the big graph here, make your x go -2, 22. So this is the min, max, x scale. Your y, make it 0 for your min, 1,000 for your max, and then go by 100. Okay, and you'll use the intersect feature, you should get 10 again. So go ahead and try that here as I'm going to the next page. Okay, the last page here. Again, I'll give you a second here to go ahead and put in your calculator. Don't do nothing. Go ahead and try it. Okay, just kind of read the instructions here. So the terms placed between the non-consecutive terms of geometric sequence is called geometric means. We did arithmetic means. It's where you have gap in the middle, you don't know the end. Okay, or you know the end, excuse me. For example, in the sequence 5, 10, 20, 40, numbers 10 and 20 are geometric means between 5 and 40. So these right here are your means. In order to determine the geometric means between two given terms, it's helpful to think of the two given terms as the first and last terms of the sequence. So I have 81. It said it wants 4 in between. 1, 2, 3, 4, 1 over 729. That's what it's asking me for. I want to think about my T1 as 81 and my T6 as 1 over 729. Okay, we're going to use that same type of method that we've used before to figure out what our, we want to figure out what our R is. Okay, that's kind of the stump that we need to figure out what our common ratio is. So we know that T6 is 1 over 729. So we're going to go 1 over, excuse me. Let me set this up first here. Let's take a step completely back. We know that T sub n equals A times R to n minus 1. But we know what T sub 6 is. Okay, it's 1 over 729. We know what our A is. It's 81. We don't know R. And then 6 minus 1 is 5. So this is how we can set it up. 1 over 729 equals 81 R to the 5th. So what I'm going to do now is I'm going to divide the 81 over. Okay, so I divide the 81 over. It's going to be to the bottom of the 729. So 729 divided by, oops. Okay, it's going to be 50, so it's going to give me 1 over 59049 equals r to the fifth. Okay, and then we're going to fifth root both sides. Okay, and after we do that, it'll give me a 1 to the ninth. So you can try your calculator here. I'm going to try it as well. Remember, hit 5 first, then hit math, and click down to number 5 on your math button where the X is. And then you're going to do 1 divided by 59049. And it kicks out 0.1 repeating, which is 1/9. Okay, now it wants us to fill in, using this, fill in the missing pieces. So 81 times 1/9 is 9. 1/9 times 9 is 1. 1/9 times 1 is 1/9. 1/9 times 1/9 is 1 over 81. And there we have filled in our arithmetic mean, or excuse me, geometric mean. Okay, we have 2 more examples. Okay, second terms of the sequence are x plus 3, x, and x minus 5. Use the concept of a common ratio to determine the value of x in 3 terms. So remember, x plus 3, I know it's variables and ugly, but it's still t1. X is still term 2. X minus 5 is still term 3. So I still want to use that same ratio where we know that t2 over t1 should equal t3 over t2. Okay, so that's going to give me x over x plus 3 equals x minus 5 over x. I'm going to cross multiply. X squared equals x squared. By fulling this out, I should get x squared minus 2x minus 15. Subtract an x squared. They go away. 0 equals, add 15. Add 15 equals negative 2x. Divide by negative 2. Divide by negative 2 is x negative 15 halves. Okay, so there's a lot of busy work, but at the same time, we're familiar with factoring and foiling that out, so we should be fine. And we have 1 left to go over. All right, so example 7. Now we're kind of getting more to the applied part about the geometric sequences. All right, so the 4th term and 7th term of geometric sequence is negative 54 and 1458. So it's another geometric means type problem. But remember, just like with the arithmetic, it gives us not the first, it gives us the 4th. So we have 1, 2, 3. The 4th one's negative 54. So that's my T4. 5 and 6, and the 7th is 1458. Okay, so by knowing that, we're going to go ahead again and we're going to cut this off. Okay, and we're going to pretend that this is my T1, which makes this T2, T3, T4. And we're going to try to figure out our common ratio that way first, and then we can work our way backwards. So we have, if T4, we can go A to R to N minus 1. So then we know that T4 is 1458 equals, we do know A now because we changed it, our A is negative 54. We don't know R, and then our N in this case, since it's T4, not T7, is R cubed. Okay, so we're divide by negative 54, divide by negative 54. So that gives me negative 27 equals R cubed. Cube root, that gives me a negative 3. So my common ratio is a negative 3. Now we know that's my common ratio, I can go ahead and work backwards and fill out the rest of my geometric mean. So I can times the 54 Negative 54 by negative 3 gives me 162. Times that by negative 3 gives me negative 486. And I can work backwards. Get 18, negative 6, and 2. So there is your answer for filling out the missing pieces in our geometric sequence from T1 to T7 now. And that would be it.